Hey guys, welcome back. Get this a little bit closer. This will be hard for you to read if it's not. You should have the notes with you as well to look at what the wave is. So this isn't on the equation sheet, but we're responsible for it, and it tells us how the velocity will change based on characteristics of the medium that it's traveling through. Usually, it's a rope, and it tells us that the velocity is going to be equal to the square root of the tension divided by the linear mass density. So in this case, the linear mass density is designated by mu, and mu is equal to the mass per unit length. All right, so a ball of string is purchased at a local hardware store. According to the manufacturer, the package contains 100 yards, 91.5 meters of string, and has a mass of 341 grams. What is the string's linear mass density? So this is going to be 0.341 kilograms divided by 91.5 meters. So about 0.004 kilograms per meter. The string's tensile strength is 90 newtons. What is the maximum speed a pulse could travel along the string? So our velocity is going to be equal to the square root of the tension over this mu. And so that's going to give us 90 newtons divided by 0.004 kilograms per meter. And it looks like it would be 150 meters. I'm not sure if this matters or not, but I am dealing with a transverse wave. It doesn't actually. This formula is going to work for both longitudinal and transverse waves. Initial wave speed is 22.6 meters per second, and the string is under a tension of 7 newtons. How would I find the tension on that string with the final wave speed of 32.6 meters per second? Please give me a detailed explanation. I have an exam on Tuesday. Exclamation point. All right, so I can find out what our linear mass density is. For the most part, that's not going to change. And I realize, like, as you stretch it, it's going to get a little bit longer. But we're going to say that it's probably pretty constant. And so I know that my velocity is equal to the square root of t over mu. I'd like to get mu by itself. So I'm going to square both sides and have v squared and mu change places. And so I have 7 newtons divided by 22.6 meters per second squared. So it looks like my mu is about 0.014 kilograms per meter. What would my tension be if my final speed was 32.6 meters per second? So looking at this equation, now I want tension by itself. And I see that tension would be equal to the linear mass density times the speed squared. I started writing the wrong velocity, so this should be 32.6. So it looks like our tension would be almost 15, 14.9 newtons. On the diagram to the right, label the nodes and the antinodes. The nodes are going to be the places where it has, so these are going to be nodes, no energy, no amplitude. Remember, our energy is related to the amplitude squared. I have no amplitude at those points. The wave has no energy at those points. Antinodes are going to be our peaks and valleys. What is the wavelength if the distance between nodes is 2 meters? So a wavelength would be, let me switch colors. That would be a wavelength, and I'm saying that it's 2 meters, and then 2 meters, it would be 4 meters. If the person is shaking their hand up and down 12 times per second, what is the wave velocity? Velocity is going to be equal to frequency times lambda. This is our frequency. 12 times per second would be 12 hertz. And so I'm going to have 12 hertz times 4 meters. Somebody with the calculator real quick, 12 times 4, 48 meters per second. All right, and each set of waves below, the two waves at the left represent two waves traveling at the same time. You are to combine the two waves and show the results to the right. So this is going to be interference. So I'm going to change the size of this. And I'm going to look at where my mins are and my maxes and try to match it up. And again, looking at your paper, you should be doing this along with the notes. So if I look, this has a value of 2, and that has a value of 1. And so I know that, actually I should say this because being off by just a little bit is going to make a difference to our results. So I know that 2 squares over, I'm going to have 2 plus 1. So 2 plus 1 is 3. So I'm going to go 1 over, and I'm going to have a point at 3. These were at 0 to start with. If I go 4 over, I'm at 0 again. So 1, 2, 3, 4. If I go 2 over, I'm at -2. And here I'm at -1. -2 plus -1 is -3. Then I'm back up to 0, 2 more over. And then I'm going to have a 1 and a 2, so that's going to add up to 3. And then finally, I'm back at 0 and 0. So this is going to be the combination of them. B, we're going to have some negative interference here. So again, I'm going to start at 0, 0. 2 over, I'm at 2. 2 over, I'm at -1. 2 plus -1 would be 1. So 2 over, I'm at +1. 2 more over, I'm at 0 and 0. 2 more over, I'm at -2, and I'm at +1. This is what I meant by adding it arithmetically. You're just adding the values of the individual points. So -2 plus 1 is -1. Then again, I'm at 0, 0. And then finally, I have 2 and -1 together, which is going to be 1. So these would add up to this. Try to make it look sinusoidal and not like a cycloid. In the top of example, I would have constructive interference. This type of interference would make something louder, even though these aren't sound waves. In the bottom, I would have destructive interference, and it would make something softer. Again, sound waves are not transverse waves. Okay, so now how do I add these together arithmetically? We'll look at our increments. From 0 to 2. This is 0, this is 0. I'm going to have a line from 0 to 2 at 0. From 2 to 4, this is at 1, this is at 0. I'm going to have a line at 1 from 2 to 4. From 4 to 6, this is at 0, that's at 0. I'm going to be back down to 0 for 2. From 6 to 8, this is at 1, this is at 0. I'm back up to 1. From 8 to 12, I have a 0 and 0. From 12 to 13, this is at 0 and this is at 1. From 13 to 14, this is at 1 and this is at 1, so I'm going to be up to 2. And then from 14 to 16, this is at 2 and this is at 0. Sorry, this is at 1. So I'm back down for 2. And then from 16 to 20, these are all at 0. So arithmetically, I'm adding them. So just adding the value. This one's a little bit trickier. All right, so from 0 to 2, I'm at 0, 0 and 0. At 2, this one's at -2, and this one's at +1. So that means at 2 seconds, I'm all the way down to -1. All right, this stays at -2 to 7. This builds from 1 to 2, and it makes it to 2 at 5. Uh-oh. Where did I move here? Sorry about that. So that means that this is going to build from 1 to 2. This is going to go from -2 and stay at -2. So at the end, 2 plus -2 would be 0, and that's going to happen at 5. So at 5, I should be at 0. I should slide. Well, that's what happened. It's got slid over a little bit. So from 0 to 2, it was at 2. Then I went down to -1, and now this went back up to 0. Okay. then this is going to be at 0 at 5 when this one's at -2. So I'm going back down to -2 up to 7. Then at 7, this one ends up at +1. This one is -1, so I'm at 0. This one's going down to 0 at 11, and this one's staying at -1. So from 7 to 11, this should be going to -1. Then at 11, this one is at 2, this one is at -1, so that would add up to 1. So from 11 to 13, I'm at 1. So that's what our combination would look like. All right, I want to add these together. It's just going to be this one up to about here. So it's just that one up to there. Then all of a sudden, we're going to have the combination of these two together up to here. So it's going to go up high. At there, this one cancels out, so it's there, and then it's just that one for the rest of it. And then it continues on. I could have done a better job. This one would just be this one to here, and then this one starts to cancel it out. It wouldn't reach 0 until here, right? Because that positive is about that negative. So this is going to be kind of like that. And then once it reaches there, this one stays at about 2 as this one drops down. So this is going to go up to about 2, and then that's the entire thing by itself. This one's easy. This is more like what you would see in AP. The rectangle plus this triangle would mean that you would just put this triangle on top because they're both on top. So this would be up like that, and then like that would be the combination of them. So it would look like that, just moving it up.